All right, so take a look at Theorem 15. So we're going to kind of work through this using our induction process. And so the idea, remember, is that we want to be able to prove that P of 1 is true. So we can take a look at this and we can see that in this example that if we follow this process, we on the left-hand side, we would have, for this particular theorem, we'd have 1 is equal to, on the right-hand side over here, we'd have 1 plus 1 is 2, 2 times 1 is 2, and 2 over 2, so 1 would be equal to 1. And so check, that would work for piece of 1. And then, like it says here, basically we're just checking our arithmetic. So we're just checking to make sure it works, just prove that. The purpose of the proof is to create a single argument that will allow us to look at infinite possible statements. All right, and let me go to slideshow. Sorry about that. I always forget to turn that over. All right, so here we go. So next slide is going deeper into kind of like looking at the reflection. And so when we look at this piece right here, what we want to take into consideration is this idea that all proofs by induction have the same outline. And so we're kind of establishing what that outline is. And that outline is that we have our basis step. And our basis step is that to show that P of 1 is true. So we talked about it a couple of different times. We'll look at through some examples. And then the inductive step is to say that for all natural numbers k, if P of k is true, so we're going to say that's our hypothesis, then we're going to show that P of k plus 1 is true. So this goes back to the domino analogy and the basis step. We show the first domino will fall over, and the inductive step, we show the dominoes are arranged so that if the kth domino falls, then the k plus 1 dominant would also fall. All right, and so we would do that through algebra, and we'll keep getting on to that. So this statement right here, as crazy as it looks, essentially what I want you to see here is that what's been added on is a k plus 1. So you can see here's your k, there's your k. We've added on a k plus 1. So then they took this and they said plus k plus 1. And we're gonna take a look at that. We're gonna look through that algebra in just a second. All right, so we've already looked at this one time, but we go through here and so we're proving that the P of 1 is true. In the inductive stage, we say if this is the situation, we point that out. Then we have to make a connection to be able to get to that spot to prove the k plus 1. So at that point, this is where I kind of gave you the brief little introduction. So this is the algebraic part. This is the part where we're going to work through the algebra to get to the spot to where we're showing what we needed to show. And so you can see here we started off and we said, sorry about that. All right, we said, okay, so let's take this original statement and let's add k plus 1 onto it. And so that's what this is, right? We added k plus 1 on. All right, to be able to combine like terms, we need to find a common denominator. So what we did is we had k plus 1 over 2 plus k plus 1. And so what we did with this situation is, I'm just going to change colors, is that we basically multiplied this by 2 over 2. Well, 2 over 2 is equal to 1, so we haven't changed any value on that. And so it's still the same thing, but because of this, it gets us what we want. This then allows us to come down here and say this statement. So now we can say that the whole thing is over 2, right? Because 2 and 2. And then what we can do is we can go through and simplify. So what happened is at this point is we looked at this and said, oh, look, there's a k plus 1 right there and a k plus 1 right there. So let's go ahead and factor out that k plus 1. That leaves me with a k and a plus 2. So that's where the k plus 2 comes in. All of that over 2, which is where this came from. So we factored out that k plus 1. Once we have that k plus 1 factored out, then what we have to do, and this is kind of a tricky thing to see. It was like earlier I was recording a video on this and I was like, I'm having a hard time seeing this. Essentially what we're showing is that if we tested this now, right? And I know it's like, well, why can't I just see it? If I tested this right now, it would actually prove it to be a true statement. And so you got to just kind of trust yourself that that's actually showing the right thing. But because this is a video, an instructional video, I want to go ahead and talk about what it means by to test this. So let's change colors here. And I'm going to hit pause and I'll kind of do the work and then I'll kind of show you the work. All right. So I just want to have you watch that all. So basically the idea is what I'm going to do is I'm going to go off of this, and I just randomly chose 4. K is equal to 4. So then using this, I said, okay, that would be 1 plus 2 plus 3 plus my K value 4 plus my K plus 1. So on the left-hand side, I add all that up, that equals 15. Then I take that K equals 4, I come over to the right-hand side. 4 plus 1, 4 plus 2, divided by 2. 4 plus 1 is 5. 4 plus 2 is 6. 5 times 6 is 30. 30 divided by 2 is 15. Check. So what we have there is that even though you are not required to prove or to show what's in blue, you can check to make sure that it actually works for some arbitrary value of K to show that it is equal on the left-hand side to the right-hand side. So therefore, we've completed this proof. We've shown that we've gone through this process, and we've did our basis step, we did our inductive step, we worked through our algebra to show this, and then the blue is just me helping you see that you verified that actually P of K plus 1 is a true statement. All right, I'm going to wrap up that video right there. Let's see. Sorry, the wrong things. All right, so pen clear. So this slide here, I'll just kind of end with this one and kind of start with this one in the next video. Although every proof by induction involves the same 2 steps, proofs by induction often require a great deal of ingenuity to complete. And so, for examples of proof by induction found in this text, the basis will always be quite easy. So if you're like, oh, that's so easy, awesome, that means you're getting it. More work will usually be necessary to determine how to show that when P of K, the inductive step, then P of K plus 1 is true. So that'll kind of be the challenging part. So let's close this one off. We'll start another one with 16, Theorem 16.